trigonometric maths. So with that being said, I think let's kick off. And let's just quickly remind ourselves what we did on, when was it? Tuesday. Oh, I almost forgot, Ms. Coco. Today is quiz day.
Quiz day
today. Yay! So those of you who have been here for a while will know how quiz day works. At about 1:45, 10:45, we end the lesson and we post the link to the quiz. And you go off and you go do your quiz using that link. You don't have to stay on the call at all, but you can until 6 o'clock when the lesson ends officially. So the quiz is a sort of progress check for yourself and for myself to see how everyone's doing, how we're understanding the content, how we're progressing. So yeah, it's just really something to test yourself. You can do the quiz as many times as you want. So you can do it, and if you're not happy with your score, you can do it again to improve your score. So if you just want to get better at it, you're welcome to do that. Okay, you get your results straight away. So it's, yeah, it's pretty neat, I'd say. It's quite a nice way to check what, how you are progressing through what you've learned this week. Okay, so on Tuesday, we did all this long stuff with first principles. And today we are going to get to differentiation using the short method. So if you've learned a little bit of calculus at school, you'll know that the short method is much better to get through than this first principles. So I just want to remind you that you always, when we differentiate, use this short method. You only use differentiation with first principles if you are told to. So in the final exam and in your prelim, you will get at least one question with first principles. But all the other questions where you're going to do differentiation, you're just going to use the short method. Okay, because you guys saw how long that took and how much working out that was. So we're definitely not going to do that every time. Okay, so what do we mean with the short method? So when we differentiate, remember also from Tuesday's lesson, we talked a bit about the derivative and what the derivative means. The derivative means the gradient at a particular point. So where we are used to working out the average gradient, we take 2 points and we use our normal gradient formula to calculate the gradient between those 2 points. When we differentiate and when we work with calculus, we are looking at the instantaneous gradient at one particular point. Okay, so whenever you think of calculus, that's what you must think of. And if you understand that, then you are really well on your way to understanding what calculus is about and what we do when we are finding the derivative. So the derivative gives us an equation or an expression that we can use to calculate gradient at a particular point. So the first rule that you learn is basically, it says to differentiate any expression, any function, we take the exponent, in this case it's this number b, we times it by whatever number is in front of x, and we subtract 1 from it. Okay, so we take the b, we times it, and we subtract 1 from the exponent. So here's a quick example. We take the 3, that's our exponent. We're going to times it by the 2, so that's 2 times 3, and we subtract a 1 from the 3, and our derivative is then 6x squared. Okay, so that's the little process that we follow. So that's the first rule. And then the next one that I'm just going to write down here is that deriving a constant makes it 0. So any constant number, so 2, a 3, or a 5, or anything like that, any number that's a constant, doesn't contain a variable, that will make it 0. And the other thing we have to keep in mind is that if we have a polynomial, so lots of terms in an expression, we're going to differentiate each of those terms separately. But also very important, when we differentiate, we don't differentiate one term and not the other term. If it is a polynomial, we differentiate all the terms at once. Okay, so there's a number of ways to sort of use notation, like notation in calculus. I'm going to call this here the notation. So notation is just a way of saying that this is what you need to find. So y dash f dash x dy by dx, d over dx, and then this capital letter dx, all of that means the same thing. You must find the derivative. In other words, you must differentiate. Okay, so that's just a little bit more about dy by dx and what it means. And this little note here, just a reminder that the derivative of a number is 0. Okay, so let's start with one or two examples. So this first example, we've basically done already. It was our example previously. So this says dx of 2x cubed. So that means we need to differentiate this. So to differentiate, we're going to say 2, the 3 times the 2, that's going to give me 6. And from my x, we're going to subtract a 1 from the exponent. So that's going to give me 6x squared. Okay, can I just see in the chat just with a thumbs up or a thumbs down if everyone is happy so far, following along and know what it means when we are differentiating? Nice. Okay. Amakli, you've got a question. You can go ahead, unmute and ask your question.
Hello, ma'am.
Yes.
Ma'am, I wanted to ask, ma'am, where does the exponent 2 come from, ma'am?
Okay, so in our original expression, we had 2x cubed. So x was to the power of 3. So our differentiation rule says that we must subtract 1 from the exponent when we differentiate. So that's where it comes from. 3,
okay.
3 minus 1 is 2.
Thank you, ma'am.
Good. No problem. Okay, so f dash x, that also means the derivative. So 2 times by 3 again. So if you're asked for f dash x, then write down what that is. F dash x, or the derivative, is 2 times 3 is 6x. And we need to subtract 1 from the exponent, so that will just be 6x to the power of 1. Okay. Try C on your own now, and as soon as you're ready with an answer, post it in the chat. Great stuff. A few people are posting already. Just remember to write your notation down. dy by dx is equal to, there's a 1 in front of the x, so we go 4 times 1 is 4x, and from my exponent, subtract 1, so it's 4x cubed. Yeah, so just be careful there, Amakle. We are working only with the x. Only with the x. So the 4 is times by the coefficient of the x. So it's 4 times 1 is 4x. And then my exponent changes. We go 4 minus 1. That's 4x cubed. Okay, let's continue. Let's do D as well. Please post your answers in the chat for D. Then I can see how everyone's doing. Differentiating 5x in question D, what do we get? A 5. Dow says a 5. Jimmy says 5. Tabile. Okay, so let's just talk about this notation as well. So this notation with the capital letter dx, Belinda and everybody just listen carefully about this notation. So the minute you differentiate, you actually take your expression and you differentiate it. The notation falls away, so you don't have to write the dx or the brackets or anything anymore. That's just like kind of like how the mathematicians decided that notation must work. I can't really say why. It's just one of those things, I guess.
I guess, ma'am, when you invent it, you get to decide how it's written. So, yeah.
Yeah. Should we just invent our own calculus notation and decide?
And then they'll decide to figure out what we've written. Yeah, sounds like a plan.
Okay. So point is, when you differentiate the capital letter dx, the brackets, all of it fall away for this particular notation. So that answer is going to be 5. I just did all the steps now, just so that everyone can understand how we got there. So the same with this notation, d over dx. As soon as you differentiate, the d over dx falls away along with the brackets. So final answer, this is a 12. What happens when we differentiate a constant number? It just goes to 0. So E's answer is 0. Okay, let's see who is awake for question G as we start, question F as we start warming up. G of x is 3x to the power of 5 over 5. Let's take 2 minutes. Give it a go. Post your answer in the chat. What about the 5, guys? That says 3x to the power of 5 over 5. Remember, if numbers can divide, then you must divide them. So for instance, 15 divided by 5 can still go down to 3. Okay, so some different answers here. Listen up, everyone. Let's have a look. It's a good idea with these types of terms that have a fractional coefficient to kind of just separate it, just write it to the side, just go 3 over 5 x to the power of 5, because then you won't forget, like some of you did, that it's also being divided by the 5. Okay, so when you multiply your exponent, you multiply it by 3 over 5, so it's going to be 5 times 3 over 5. So this is what you multiply by. Notice that I'm still not writing over here in this first step. I'm still not writing the derivative. I'm going to write the derivative now, g dash x, because I'm going to differentiate now. So only when you differentiate do you write that down. So 5 times 3 over 5, you can do that on your calculator, no need to do that in your head, but 5 times 3 over 5 is going to give you 3. And then we are going to subtract 1 from 5. So that is x to the power of 4. So good on everyone who got 3x to the power of 4. Everyone else, check your mistake. Make sure you know why you maybe didn't get it right this time around. Most of the time it's that pesky fraction that we forget about. Okay, any questions so far? Pop them in the chat, pop them over to Miss Coco. And we are going to start now to take it up a little bit of a notch, one more notch, before we're going to basically take it up 3 notches this evening. So we're taking it up a notch now. So golden rule with differentiation is that your expression, before you differentiate, your expression cannot have any brackets, no brackets, no roots, no, not roots, just roots, no roots, and no algebraic fractions. That means we cannot have an x or an x cubed or an x to the power of 4 in the denominator. Just so for both the brackets, our solution is going to be to multiply out brackets. Okay, so multiply out. And our solution to get rid of roots and fractions, algebraic fraction, is to use exponent laws. And I think before we start this, let's just do a bit of a sidestep. And let's just talk a little bit, just some quick exponent laws you need for differentiation. Differentiation. If we have a coefficient in the denominator, that doesn't matter. Number fractions are fine. It is if you have exponents in not exponents, variable fractions, that you have to change them. Okay, so the first thing we kind of have to remind ourselves about is this exponent law that says if you have a variable in the denominator, like say you have x squared, to make that positive, we have to put it above the line, this line here where that divides the numerator and the denominator. So to do that, we make the exponent negative, or we change the sign of the exponent. That's the first thing. That was something you would have learned in grade 9, hopefully, and again in grade 10, and you might have forgotten it in the meantime, but this is super important for calculus to get our algebraic fractions to be not in the denominator, but to take it into the numerator or take it to the top. Now, the second thing we need to remind ourselves of is if I have x to a power, any power, in this instance, I'm making it up, say it's 3, and there's a root, then to change that into an exponent, I say x to the power of 3, so I take the inside exponent divided by the degree of the root, so 3/4. So inside over outside. A couple of examples. Root x is x to the power of 1/2. The cube root of x we write as x to the power of 1/3. And if we have an exponent as well, then we take the inside exponent divided by the degree of the root, like we did with this one, x to the power of 3/4. Okay, so these are two little skills that you need for differentiation, because you cannot ever differentiate if you have a root or if there is an x or variable in the denominator of your expression. You first have to rework your expression so that all of those things look different and are gone from your expression or put in a different form. So I'm going to do this first one together, and then you guys will start working on you guys doing the same ones or the same ideas. So f of x is 1 over x to the power of 2. So here we have an x in the denominator, x squared in the denominator. So to change that, because we cannot differentiate it yet, we make it x to the power of minus 2. That's fine. We can differentiate that. So we write our next step, which is our differentiation step. So we're going to say minus 2 times a 1 is a minus 2x, and subtract 1 from the exponent. Minus 2 minus 1 is minus 3. Okay, just give me a thumbs up in the chat if you're happy with that and you understand how I got that. Okay, lots of thumbs up. Excellent. Okay, excellent. Right, let's go to B then. Okay, so f of x is 3 over x to the power of 4. Okay, so I just want you to put in the chat what you think we must change this to so that we can differentiate it. In other words, what will this change to if we put the x at the top? Just put it in the chat. Yeah, I think your buttons there are getting, your buttons are misfiring. Okay, good stuff, everyone. Yeah, so we're going to put this into 3x to the power of minus 4. The 3 stays where it is, okay? The 3 is already at the top. The 3 is not a variable. The 3 is a coefficient of the x, so we don't stress about the 3. It's just the x to the power of 4 that needs to change to x to the power of minus 4. Right, we differentiate. Minus 4 times 3 is going to go to minus 12. And subtract 1, that's going to give me minus 5. Okay, everyone, give it a go for question C. And we'll check in about 2 minutes. Post your answers in the chat when you're ready. Okay, all way to off the mark there already. Okay, so Cassandra's asking, is it okay to leave our answer like this? Okay, so sometimes we are asked to change it back to positive exponents. Okay, so let's just be clear, a variable or the whole expression can be negative. But in this case, we have an exponent that's negative. It's a negative 5. And yes, sometimes you're asked to leave it with positive exponents. But I'm not so concerned about practicing that this evening. We can definitely practice it another time or next time. Today we are just getting to the point where we all understand that we have to get our exponent to the top and then how to differentiate. So our focus is on that today. Another time we'll focus on changing it back to a positive exponent. So I just want everyone to get to that point this evening. Okay, so we've got lots of answers in the chat. Let's see who has got it right and who's on the money here. Okay. So for C, we have f of x. And if you remember what I said a few sums back, if it's a fraction like this, just write it a little bit to the side. And our x to the power of 3, we're going to change to x to the power of minus 3. Because we are taking it to the top. That's fine. We can differentiate that the way it is now because we don't have an x in denominator. So our minus 3 is multiplied with 1 over 2. That gives me negative 3 over 2. Negative 3 times a half is negative 3 over 2. And my x is going to go to minus 4. X to the power of minus 4 because we subtract 1 when we differentiate. Okay, so I think a few of you got it. Just be careful if you maybe said 6. We do not, guys, listen very carefully, especially if you got an answer of minus 6. We do not take the 2 up, okay? The 2 stays where it is because the 2 is not even a 2, it's a half. That coefficient is a half. So you don't take that, only the x. To make sure that you leave here tonight and you understand that. Otherwise, all your differentiation will be affected by that, okay? So that coefficient is a half, and we're going to multiply our negative 3 by the half, which gives us the negative 3 over 2. Okay, we've got plenty more opportunity to practice that. And here comes question D. So for question D is actually much easier than it looks because we can actually go x to the power of 3 divides into x to the power of 6, right? Because that's like an easy grade 8 division that we've got there with the exponent. So we can go that f of x is actually 2x to the power of 3 because we subtract it. And then we differentiate and we get 6x to the power of 2. Okay, now see if you can do E, same principle. The x squared and the x to the power of 5, the bases are the same. We're dividing, so we can do that division and then differentiate. So give question 3 a go. And for those of you, which one? Mohammed says it's 2x to the power of 2. No, Mohammed, be careful. We don't divide the 3 into the 6. We subtract it. That's what the exponent law says. If the bases are the same, we subtract exponents. So 6 minus 3 will be 3, not 2. Okay, give question E a go. Those who are getting a 9, I want you to check again. Check again. You are not bringing the 3 up. The 3 is not a 3. It's a 1 over 3. And you're not bringing it up. So if you got a 9 in your answer, check again. Go back and work it out again. Think about what I said here in question C specifically. So for those of you who are doing E and maybe struggling and getting a 9, do this. Remember, separate out that fraction. Just write it a little bit to the side, and then you have your x squared over your x to the power of 5. This is going to be the coefficient. And we're not taking it up, like I've said now a few times. We're leaving it as it is. What we can do, however, the bases are the same. We can subtract the exponents. So we are going to subtract a 5. So the expression that you should have that you're now going to differentiate is a third x to the power of minus 3. Okay, so check now that your expression that you're differentiating is that, and then differentiate. Going to give it a few more seconds. So we go negative 3 times a 1 over 3. Negative 3 times 1 over 3. No need to do it in your head. You can just do it on your calculator as well. If you're really not good with fractions, that is minus x. And then we subtract 1 from the exponent, and that gives me x to the minus 4. Okay, so Riabilwe, I see some of you are getting that. Some of you went back and fixed. Well done. That's what we're doing, guys. We are learning and fixing our mistakes. That's what's important. Okay, awesome. Don't get caught out by that fraction again. So we're going to do one last one. Question F. Question F is over here. Let's see if you get caught out by the fraction again. Okay, let's see, are we catching on? Looks like we are. Good stuff. Okay, so let's get that 5 over 4 a little bit to the side so that we know that that is our coefficient. That is what we are going to multiply by.
Mohammed, you cannot just agree with Liam. You need to test the answer as well for yourself. So you also have to do the working out. I can't believe you're like cheating off of your friend during an online lesson. Yeah.
Just letting him do all the typing, and then, yeah, no, I'm agreeing. I second that.
Okay. No, I believe you. I believe you. All right, Mohammed. I know you didn't.
Day before breakup day, Miss Coco, maybe we can give him a break. The benefit of the doubt. Okay, so the x to the power of 11 is going to subtract from the 9. We get x to the power of minus 2. And it looks like some of you have really learned from your mistakes. So we are differentiating minus 2 times 5 over 4. I'm getting my calculator for this one because it is the end of term. So minus 5 over 2. My brain cannot process that anymore. So subtract 1. X to the power of minus 3. Yay! I see lots of good answers here. Well done, everybody. Excellent. Well done for persevering through that.
So, ma'am, Tapisa is asking, so we can't use the exponent with the largest number to subtract from. I assume she's talking about numerator and denominator in this case. Exponent.
Yeah. So if you did that, what would happen is, so if I take this as an example, the f of x, and it's 5/4, and I subtracted the 9 from the 11 instead. So I would still have this. I'd have x squared at the bottom, and then I would still have to take another step to take it up. So kind of just subtracting from the top saves you that additional step of still having to take it from the bottom to the top if you went the other way around. Okay, let's do one with a root, or one or two with roots, and then we need to start our quiz. Hey, okay, so question G. F of x is root x. Move this. We'll do this next time. Okay, so to remove the root, we're going to rewrite this as f of x is equal to x to the power of a half. So if your exponents are rusty, I hope you wrote down those notes or took a screenshot of these little notes about how to change from a denominator to a numerator and making the exponent negative, and then also how to change from a root. I really, if I need to put that back up at the end, just let us know. Amachle is asking, where is the -1 coming from? I'm not sure which question you referred to. The minus one that we subtract is just part of the rule, okay? So this person, Newton, who invented calculus, he basically said this is the rule. This is how you differentiate. So who are we to argue with a famous mathematician? We only follow what he says. But we also try and understand. So well done for asking, but I think that's just part of the rule. So a half times 1 is a half x. And then we subtract 1 from the exponent. Okay, so if you're wondering why we're doing that, that is just part of the rule. And our final answer is a half x to the power of -1/2. And let's end off with question H before we start our quiz. F of x is the cube root of x. Okay, so try that one on your own and post your answers in the chat when you're ready. Okay, so some answers are in. So we first just do our changing of the root to a power. So that's x to the power of 1/3. And then we differentiate, and I see quite a few got it right. Just be careful with working things out, guys. Just use your calculator. Don't be shy. Okay, so even if you have to work out what is 1/3 times 1, Just do it so that we can get it right. It is worth it in the exam to just get these marks. Okay, and we're going to subtract 1 from 1/3. And that gives me -2/3. Okay, well done. I see a few of you got that one right. Excellent. Excellent. Okay. Right, so we're going to end it there. I think we're off to a good start, and I think we cleared up quite a few misunderstandings about the exponents and the differentiation. We're going to differentiate some more on Tuesday and on Thursday next week. So I hope to see you then. Over to Miss Coco for the quiz.
Awesome. All right, guys, I'm going